Hello and welcome to the Observability Heroes. My name is Rainer and I'm the founder and an observability nerd. A little bit about me later. So I love observability, and what I do love is the current tendency towards OpenTelemetry, because OpenTelemetry is an absolute game changer. And let me tell you why. I did have the opportunity to go to a meetup and talk a little bit about why it is game changing. And well, let's take a look. So OpenTelemetry is something that is in the news all over the place, and it's especially interesting for me because, well, who am I? I'm a troubleshooter, I'm a computer guy and a problem solver. Computers are here to solve our problems, but sometimes they create some, because we tell them what to do, but sometimes we don't know what we told them. And this is where the troubleshooter comes into the game. And in the last 22 years, I've been in the space of APM or observability. And here's my head a little bit in the way. I used to be with Wiley Technology very early in the 2000s, like 2003. And Wiley was the first that introduced bytecode instrumentation and a permanent monitoring of a JVM. Yeah, finally I could look into a JVM and see what's going on. And from there, I went on to a company called Dynatrace when there were just 2-3 handful of people based in Linz, Austria, and getting into the market, which they dominate right now, I would say. And here I took the next step, a different approach in APM at that time, and that was good. It showed me where we could go with the technology. Where I went was then AppDynamics, because it brought in a new twist in the whole APM game, made things easier, nicer to grasp, and focused on business transactions, not so much on technical details. But as it is, times are changing, and I ended up in Instana. This was around the time when containers became great, when Kubernetes was there, and you looked for something to monitor it, and the older guard was just not really capable of dealing with the permanent change and the massive amount of small services, or so-called microservices. And I loved Instana. It's still a good product. It's now in the hands of IBM, and they move it forward. But why I like that so much, I'll tell you later when we come to the vendor lock-in setting. And from here on, I am now consulting companies as an observability hero, or turn them into observability heroes. So, but why is observability so nice? It's not because of my hobbies, but it is a natural outcome. So observability is not monitoring. Monitoring is a subset, and we came from there. We came from logs to now distributed tracing. And that is because we went from big to small. Now the first behemoths out there, some are still working. I would say they're like elephants. They're big machines, and they do a lot of stuff. They have a great memory, and they're easy to track. And just, you don't need a GPS tracker to track an elephant. You just need binoculars. It's just there. And you know how they work, what you feed it, what comes out, what goes in, and so on. But it changed. Now it's no more an elephant, but a bunch of ants, all doing their job. They're doing it quickly. They move stuff, but they're not very easy to track. And if stuff is not moved, it's pretty hard to crack which of the ants or which group of ants is responsible for that. To wrap it up, we went from terminals to the mainframe over a client-server architecture in the 90s, 2000s to 3-tier and web service architectures, which turned into containers and microservices, and now we also have serverless. So the bits that we want to monitor, that we want to look at, that we want to get data from, becoming smaller and smaller. And if you don't believe that, It's for real. This is, if you see it live, it's like an anthill. The little dots are actually moving, and this is a dependency graph of a couple of services. That's all in there. Application services in different languages, serverless, databases, messengers, all of that. And they're all working together and it all works. But if something doesn't work, which end is to blame? And which one do we need to train to make it better? Now, this left us with a heap of technology. Over time, not only the applications, well, evolved, but also the technology to monitor them. People brought in new ideas, but the old ones are still around, and this is just a little bit of it. So you see companies like Honeycomb, which are on the latest forefront, the vanguard, so to say, and we have Zabbix and Nagios, which are represents of the old system monitoring type. There's Loki for logging, there's, well, bytecode instrumentation there. You see Datadog, Victoria metrics, Victoria logs, all of that. If I write down every single bit of technology that has to do with observability and also the company names, this page would just be blank. It would be white. So that's an issue, because all of those are one for one and none for all. Nothing like the 3 or 4 musketeers. It's my solution or nothing. And that comes from the evolution. I don't blame them. It's just, it happens. You try to fix something, or you try to put something new in, and you develop it. But for example, when you want to show the dependencies between your microservices, you need tracing. Each of the vendors out there has tracing. Well, most of them. But they all have their proprietary internal tag to trace it, to propagate the trace context, to propagate the baggage. There's a standard, a W3C context propagation and baggage standard, which is implemented by OpenTelemetry. But the rest is just, well, historically grown or hysterically grown sometimes. Yeah. So this is one thing. The others are data types like metrics. Metrics are extremely vulnerable for naming. You name it differently, you don't find it anymore. And guess what? Each vendor had their own naming convention, their own naming scheme, and also sometimes their own calculation methodology for percentiles or averages, medians, all of that. Different algorithms, and so things are partly not comparable. What is also not comparable is the transport layer. You have to get the data from the agent, from the application, to a backend to work with it. Now, this is usually done with HTTP, a stateless protocol, and the data is wrapped inside in a proprietary format. So you could not interoperate between those because they didn't understand each other. They still don't understand each other. That means also when new tech comes into the game, like containers 10 years ago, it needs new approaches, but it's hard to plug it into the old systems. Hence, we have this heap of technology around observability. And that means it's finally time for a standard. And this is where OpenTelemetry comes to the stage. Yay! So what is OpenTelemetry? It's a CNCF project. CNCF is the Cloud Native Computing Foundation. They had their big meetup last week in London, and they're renowned probably for Kubernetes, Argo CD, and a couple of others. There are lots of projects inside CNCF. And the number one project since this year is OpenTelemetry, because it's the number of contributors there. It is here and it's here to stay. People are contributing, and Kubernetes is kind of, still developing, but no, the main part is done. Now, off to monitor the stuff. It derived, or it came from Open Tracing and Open Sensors, which were two standards that finally merged into OpenTelemetry because it didn't make sense to have two standards that were fighting each other. And that was the time when it started to be adopted by the industry. That means it's getting traction. That's why it's number one project in CNCF, because, we're there now. And why? What is OpenTelemetry? OpenTelemetry is an observability framework and a toolkit. Nothing more, nothing less. It is not a product that you download, install, and everything's smooth. No. What it consists of is a layer that gathers data. It's agents, or you can call it SDK or API. At the heart, there's an API for different languages like Java, Python, Go, a lot of others. And there's the SDK, which is the reference implementation, so to say. You could still use the API if you have other ideas, but there's one ready-made for you. And those are the things that run inside your application, your service, to gather data and send the data out. And the data then usually shows up in a collector. You could send it directly to a backend as well, but the collector is a nifty piece of software that you should not neglect. The collector itself can not only accept data and forward it to the backend, the endpoint of your choice, it can also do something with it. It can transform data, it can process data and streamline naming, for example, or add labels that did not exist to make it easier to work with the data afterwards. You could redact data, you could have security data in there. It's also capable to work as a gateway in a load balanced fashion, and that makes it scalable. It's extremely flexible, but that also means you have to know what you're doing. So it's a framework and a toolkit. And this collector architecture is something that helps you a lot in your way in observability. So let's take a look a little bit what it actually does. So the agents collect the typical signals for observability, which means logs, metrics, and traces. Logs can be integrated. You could just suck in the logs that are there. You could use InfluxDB, for example, or FluentDB, or others. Or you could integrate it into the instrumentation and directly create the log events inside your traces, for example. Metrics, the same. You could accept Prometheus, you could forward it to Prometheus, you could create your own, and the collector is the one that's responsible for it. And then the heart and soul for me are the traces. They weave this all together. And the tracing here, especially the trace ID and the context propagation, is an adopted standard meanwhile. And lots of vendors out there accept traces in the OpenTelemetry format. Talking about format, the glue that holds this all together is a protocol called OTLP, the OpenTelemetry protocol. It is based on protobuf and uses gRPC and HTTP to send the data around. So that protocol is actually what makes integration so easy. Lots of vendors adopted OTLP and are capable of sending their data out in OTLP or accepting OTLP data. And this is where the next bit of software comes into the game. That's the collector. The collector collects data, that's hence the name. And it consists of a couple of internal components called receivers, processors, and exporters. You can guess what they do. So the receivers accept data. Then the processors transform and sometimes analyze the data, create new data out of it, or actually dump data, and then the exporters send it over to the endpoint of your choice. Pipelines are the definition of what these three things are doing together. And on the right-hand side here, you see a screenshot of a visualization of OTelBin. OTelBin is a cost-free tool. It's open source. Oh, is it open source? You can contribute in any case. And what you can do is you drop your collector configuration inside it, and it shows you what collector does. It visualizes it. So here we see we have a trace pipeline that's on top that receives traces via OTLP, batches them, and then sends it off to, in this case, -0. Metrics does a little bit more. It receives OTLP metrics, it creates host metrics, and it also scrapes metrics from Prometheus, and then batches them together and sends it also to -0. And the same for logs. This is what the collector does. Receiving data, processing data, and sending it off. And this is, as I said, extremely flexible. But this should not be a training about OpenTelemetry, but we're talking about why this is a game changer. Well, first and foremost, it's a standard, but the standard is nice, but it's also a standard that is adopted. Most of the commercial observability vendors out there are accepting OpenTelemetry traces or metrics and are capable of sending it to an OpenTelemetry protocol based endpoint, so to say. So they embrace it if they can. If they have the technology means that allows them to embrace it. But more important is actually that the maintainers and developers of frameworks like Spring Boot, like Flask, or of commercial solutions like Shopware, which is also open source, but yeah, it's a commercial open source solution. They do support OpenTelemetry instrumentation by heart. Yes, there is a ready-made Shopware instrumentation. You just plug it in your PHP and there you go. Everything's ready. And this is the game changer number one. Finally, I don't have to do this on my own. I don't have to rely on a vendor to do this for me. No, the maintainers can do it themselves. And that's big. More about that in a second. We have OTLP, adopted industry-wide as a standard. And we have a scalable collector architecture, which helps us dramatically in getting all the data to where it should be. So, we're off to mission observable. Yes, Lucylog, Terrytracer, and OpenTelemetry are on their way to make IT systems more stable and fight the unknown unknowns. They're ready, because they have a toolkit that allows them to tackle any problem anytime. Or is it a sci-fi? Is it finally that the trace awakens? The force is strong one. No, the trace is strong with this one. Well, traces are, for me, the heart and soul of modern observability, but more about that later. So, why is OpenTelemetry now changing the game? Because all of that, what I just said, is something that's out there in the market for quite a while. I've dealt with that for the last 22 years. It's commercial. It's there. But it's a game that we want sometimes to change. And the first one is freedom. Freedom of technology and escape the vendor lock-in. What do I mean by that? A beer for anyone who could tell me what this is. And ex-colleagues don't count. You get a beer anyhow. So this is a text file called a PBD file, a Probe Builder Directive, which was at Wiley Technology Interscope times the definition of my metrics. So this was the definition of what method to instrument to get metrics. In our case, this was for Tomcat, and the first two lines are about sessions. How many active sessions do I have? Well, we counted the activate method and the passivate method in this sessions package, and there was a special, method that incremented that count or decremented that count. A method trace incrementer and decrementer, you can see that. And then we put it in a metric. That was called Tomcat pipe HTTP session active count. Now, you had to write this for all of the Java code. A lot came with the product, but if there was something new, you had to write it, you had to maintain it. And it was not usable by any other solution out there. So, if you wanted to change things, it was tough. Proprietary technology, like instrumentation, context propagation, and correlation of data, makes it hard to coexist with others, because they're usually made for themselves. No coexistence, no interoperation, no exchange of data with any other vendor out there. Yeah, you may have a REST API, but you have to go through the, I stripped this, I marshal this, I unmarshal this, it's JSON, I have to parse the JSON, yada yada yada, all the jazz. So that means changing your solution is a lot of effort. You invest development cycles, restarts, configuration changes, all of that. And for what? Basically to get the same data as before, just in a different format, plus something. Hence, change is usually slow in that field. There are cost explosions then. There's high maintenance, because you try to do something that a product, for example, was not made for. The architecture doesn't do that. And that means it has less value, but more costs, which over time, it's not good. Let me show you what I actually mean. We have a trace here this is from Instana. The trace has a trace ID, as you can see on top. And this ID is what needs to be propagated. I get lots of attributes and labels, which are also can be standardized. OpenTelemetry standardizes them, but usually the vendors themselves have their own naming, so they're not comparable. So things like request path, URL, route ID, the thing maybe is also called differently internally, and do just as a label here for the screen. But more important, when I take a look at the whole trace, which consists of 8 spans in this case. So each block that you see here, each rectangle or line is a so-called span with an individual information set, like duration, like start time, end time, and all of that. The first one starts the trace, so-called parent, and that one creates a trace ID, and then it propagates it to the next one. So these spans know that they belong to a trace, and that the backend knows that the span belongs to that trace. Now, you see that the first one is get, then there's also a database in there. But what if the first 2 are monitored by Instana, and the next ones are monitored, let's say, by Dynatrace? It would stop there. You would see a call to get product, the purple one, but from here you wouldn't see anything because you had to integrate the Dynatrace trace, the pure path, and you just couldn't. A different way of propagating the trace ID, and yeah. So that means you cannot mix and match your products. You have to rely on the vendor following up. And if a vendor doesn't support your framework, for example, that you use, like database connection framework, pooling framework, all of that, you, in case of Instana, you file an RFE. You could use an SDK, but that's kind of tedious. So you file an RFE to support that finally, and then it takes a while. Sometimes it is quick, sometimes it takes forever. And this is the same with most of the vendors. Now, when I talk about standard and adoption, it means we can speed up things. The screenshot here of that says agent installation, install Java agent, and the other 3 is from a recent snapshot from a documentation of a tool that is 17 years on the market. It supports 4 languages natively: Java, .NET, Node.js, Python, no Go, no PHP, no Ruby, no .NET Core, no Rust, no Scala, no Kotlin, nothing. All of the things that are used for microservices are, well, not there. And that means you would need to change. You would need to find a different system, but that needs to be interoperable. It should be maintained by the makers. For example, Shopware, Shopify do automatic instrumentation, and you're just golden with that. Extensible if you want to add your own stuff, and fully configurable, and that's what OpenTelemetry is. So that makes you escape the vendor lock-in. Another thing that is kind of tricky, and you may say it's boring, is about naming. Semantic conventions. This is one big thing in OpenTelemetry. It has a list of how to name things, how to name attributes in an HTTP traffic and an HTTP request. Because, well, naming the same is making life so much easier. And when you take a look at the name tags here, Christoph, Christopher, Christina, Christine, Denise, Dennis, Dominique, Dominique, Dominique. There are many ways of writing names in different languages, and rightfully so. But in IT, it makes it just harder to find the information that you want. You search for it, and if you think, looking up names in the table is boring, trying to find a metric that gives you the CPU for a host and having like different ways of writing a host name is more boring, at least in my eyes. I'm not here to puzzle data, I'm here to solve a problem. And if people decide to use host.name, host name without a dot, host minus name, host underscore name, name host cluster, or just name because it's in a host context, yeah, that makes life not easier. It also makes the migration of dashboards and alerts almost impossible. Why? Well, take a look at this. This is a JSON for a dashboard in, I think, Dynatrace. And the most important thing here is the metric name. DSFM server service calls processed. Now, even if this JSON format is like kind of Perseus-like. I could import it into Perseus and I still wouldn't be able to see anything on the dashboard because the metric name is different. And if we have all agreed on the same name, it makes my dashboards, my alerts, and other things that rely on metrics much easier to migrate. And think of it another way, when you go to a website and on one page it says add to cart, on the next page it says add to basket, and on another one add to bag, it's the same thing, just named differently and just confusing you. Oh, where's my cart? Oh, there's no cart. Oh, there's a bag. Oh. And yeah, that's what we want to avoid. Hence, semantic conventions are really, really good. And sometimes boring. Yeah, I give you that. Now, number 3 of the game changers. Finally, we're getting real observability by design. What do I mean by that? Well, we have signals, not pillars. Pillars are for themselves, and as Honeycomb put out in their blog, I think 2 years ago, take a look at they aren't pillars, they are lenses article. It goes in depth into what I'm going to tell you in brevity. So, when I have metrics, I get a picture that kind of says blue-hued because I look at it through a metric lens. And I see the generic picture, but I don't see the details. Now when I look at it from a trace perspective, I see more details, but I miss other things. It's not like that high contrasted as the blue one. And if I look only at logs, it's yet another difference. I see the table much clearer with more detail, but I'm lost in a couple of other things. What we need is this. All data together. We need traces, events, and metrics. And if I overlay the colors, this is the picture that I get. All the details, fine-grained, and I can take a look. And this is what observability with OpenTelemetry brings you. A possibility to bring this data together, to weave it together, so that you know where something happened, what happened, and when it happened, and who is suffering, or who's responsible. Because events tell you what happened. Metrics tell you when something happened, and traces tell you where in the whole context they happened. But all in all, you need all of this information to solve a problem quickly. Now, when I take a look at metrics, I see, oh, there was a problem at probably 2:30 in the afternoon. My response time, my latency, jumped to 2 seconds, plateaued there, and then it dropped back to normal. I also have log information. I see logs, SQL error, connections not available, request timed out after 2 seconds. And that means I'm onto something, but I need these in connection. If I only have the metric, it doesn't tell me anything. At least if I don't have the dependencies. Now the trace would tell me that I have 4 components that have a response time of 2 seconds, but only the last one is responsible for my problem, the connect, that times out after 2 seconds. This is what the log tells me, but the trace puts this all in context and together and makes it much easier, so that I can really find the culprit. Oh, my database is gone. You got a database and you're happy and you're fine. Yeah, that really works. So let's get going and take a look at the examples that we have here. So what's the deal with the vendor lock-in? It's, well, being able to choose your own backend, for example, is one of the things that I can actually show pretty easily. So let's get started here and take a look at a little demo application that I have here. So let's make this a little bit bigger. This is a little application that you can actually look up on GitHub. It is completely there. It's training book info from Ramos. Link is in the description. And here you can follow the steps, set up the whole thing without instrumentation and with instrumentation, and then get the data. It's a little thing that consists of 4 different services in 4 different languages: Python, Java, Ruby, and Node.js. And it's nothing special. It gives you information about books, like the Comedy of Errors. And you can sign in, sign out. Oops. So yeah, you can guess the password. And use this as a regular user or as a test user. And then do some repeats. And at the same time, we have a shopware system here. As I said, shopware supports OpenTelemetry, and all I needed to do was run this composer command, shopware OpenTelemetry, and set a couple of environment variables to get this going with OpenTelemetry. And yeah, this is a regular store. I could check out the store, get my information about electronics. This is the demo store, so you can run this in a Docker instance in 1 minute, or Docker Compose in also a minute. Go to checkout, and it's a complete shopware system. And once it's enabled, let's switch over to Grafana. So right now, I put everything in Grafana Cloud, as it has support for all of these things that we want: metrics, logs, traces. I want to take a look at the traces here. I'll see I have traces for product page, for shopware, for details, ratings and reviews. This is by service name. And I'll just take a look at shopware, add these two filters, and then go to the traces. This is just, to get through it. Main product. And here I have the complete trace. You can see the whole trace over time here, 123 spans, which is kind of something. And most of them are database related. So here are some DB statements which are, whoa, that's good. And I may be happy with that. Also with the way I look at metrics. Let's take a look at the metric explorer here. I can go through all the metrics that we collect, and then I'll go to client request duration, check and see, do we have a route here? And this is where it already starts. I'll have to get my head around last name, request method, status code, instance, job. Let's see what job I have. It's book info reviews. That's the job here in my client request. Okay, fine with that. But I'd like to have something different. So what do I need to do? I need to change the information for my OpenTelemetry collector. So let's take a look what my OpenTelemetry collector file looks like. It's a YAML file, and let's make it a little bit bigger. It has things like basic authentication setup for Grafana. It picks it from an environment variable. It has some file logger setup, some receiver. But what I wanted to go for is the exporters. So I have exporters to -0 set up, to Grafana, and to Prometheus, and Prometheus remote write. And now let's take a look at my pipeline definition. This is where it all comes together. So right now it is set up with an exporter going to Grafana only, but I can, with a flick of a switch, comment this line out, the other one in. I decide to send it not only to Grafana, but also to -0. I save the file, and then I restart my collector, because the configuration file is copied into it during the start of the container. It's the easiest way. And I'll start it again, and that's it. So I changed 3 lines. Well, of course, I would have to add the OTLP-0 information in there as well, so I can use it. But what happens now is that from this one here, where we basically get nothing, it starts to get data already. So I haven't done anything. Let's do something here. Add something to the shopping cart. Continue. Add some clothing. Yeah. And here as well. Do some reloads. You probably can't see it so fast. And then go back, and I'll see, yeah, the log count went up. It's a different view, a different way of looking at things, and I can take a look at resources and can already see here my information map with my shopware, with book info reviews. It will connect them eventually, because yeah, it takes a little bit of time to actually take the data and then make sense of it. And when I go to tracing, I could see all my spans here, and whoa, it's a different approach than the one that Grafana has, but it's the same data. Whatever I prefer, whatever I like, I can go right here. I have the span count, I have the error percentage, the duration, and with a button click here, I can filter this out, so I don't want to see the health checks, and I may want to group this by something different, or just go for service name. Is shopware, and now I have all the spans for shopware. Okay, just pick one, go for the full trace, and well, it's the same thing, just in a differently shown, but it's the same type of data. And this makes it easy for me to decide which is the tool that I want to go forward with. And also here I can see all the database queries. Test selecting from product page. I haven't set the service name is shopware, and now I have all these database statements from shopware as a table. I can also group them by service name, or and go into a triage, all based on the same data. It's just a different way of looking at it, and this is what's so fascinating about OpenTelemetry. Now, how did I set this up in my application? Well, let's go into training book info here. These are all my services. This is the Docker Compose file, and I didn't change anything in my application. For example, this one here is a product page. That's a Ruby service. Ruby? No, Python, sorry, Python. Python has auto instrumentation. And all that I needed to do was set these environment variables. That's it. I set them here in my Docker Compose file. Tell them where to send the data, which is my collector endpoint. That's it. And same for, where's my Java? Reviews is Java. Java needs actually an agent file being deployed, but in this case I can just copy it over from my local one with the JVM options being set, and then it will look for this file here and take it and do the auto instrumentation. That's all that's needed to get this done for Python and for Java. With others is probably not that easy, depends on your language, but we can have a talk about that. And that's it. Now I have my application set up for monitoring, for observability with OpenTelemetry, and then I can decide which backend would I like to send this to. So let's take a look further here. The collector config, as you've seen, pretty easy to look at. It's a YAML file, and I define my endpoints here in the exporters, for example, my -0 endpoint, and then I'll use it in the pipelines. That's basically it. You've seen the comparison, just a reminder that there was something. Right, and that's basically it for why OpenTelemetry is such a game changer for the observability practice, for everybody who's into observability. We're at the start of a, I hope, big wave, and yeah, let's do this together. If you need some expertise around how to get this set up, this is the challenge with OpenTelemetry. It's a community approach, it's contribution based, and that also is true for the documentation. So let's make me a little bit bigger. So documentation in OpenTelemetry is quite a bit of a challenge because it's there, but you not necessarily find it easily. And this is where getting into another community or getting into the ring with someone who has already done that can prove very helpful and time-saving. But for all that it is, it's a great move, it's adopted, and it is really, really something that we were all waiting for the last 2 decades. Yes, so I'm going a little bit into detail in a couple of follow-up videos, also in why agent setup and instrumentation is such a challenge. And yeah, subscribe to the channel and be informed, or ping me directly if you have any questions around that. I'm for sale. You can book me for consultations around OpenTelemetry and also other systems. As you've seen, I worked for a couple of APM companies before. And with that, I say enjoy the rest of the day, the rest of the week, and see you around here on the Observability Heroes. Yours, Rainer.